Hello everyone and welcome to another video on Dynamo for Alias. Okay, today in this video I'm going to show you how to do something like this, but using a NURB surface and Dynamo to trim the NURB surface with these little circles. And we'll try to do first with an attractor point, and then once we get that sorted, I'm going to try and do it with an attractor curve. So let's get started. So first of all, I'm going to put a plane inside of here, scale that up, do a bit of non-prescale, here we go, and deform it a little bit. See how that looks. Yeah, that looks all right. Anyway, we don't need that to be very complicated for today. Anyway, now let's draw our curve. So in the example we have here, the curve starts around here, and then all right, got it. Does something like this, I believe. Yeah, okay. We could even go a degree lower. Right, that's good enough for now. Okay. I like to have my curve above the surface, just because. Let's first of all save a file onto my desktop. Dynamo tutorial. And now let's start Dynamo. Okay, so I have Dynamo on my marking menu, but just for those of you who are new to this channel, the Dynamo tool is on the transform tab inside of the palette. So once Dynamo has started, we have it showing here. Let's make that full screen and start a new file. Okay, so first of all, I'm going to select and send my surface into one node. Okay, click to fit the surface into the view, and insert another select from alias node, and this time select the curve and send it. All right, so now we have our surface and our NURBS curve. Perfect. Okay, so first of all, what we're going to do is do this bit. So as you can see, it seems like it's using the isolines of the surface to plot pattern points, so to speak, onto the surface. So let's do that first. Go back to node view. And what I'd like to do is to group and name my nodes so that I know I don't have to click, hover, and be like, okay, this is the NURB surface. I mean, in this case, it's highlighted. But what I like to do is just go like this, group it, and say send the surface. And on this one, I say send the NURBS curve. Right, and save it so that if it crashes or something happens, we can save. We have our work all backed up for us. Tutorial. Okay, save. And okay, so we said isolines on the surface. So get isolines, and or even we don't actually need the isolines. We could just do point at parameter. And here we go. So we have a surface. And in this example, we have 1, 2, 3, 4, 5, 6, let's say 20 points this way and 25 points that way. Okay, so UV. So the UV parameter space goes from 1 to 0, 0 to 1, and we want 20, let's say 20 points, 20 points here on the U direction. Okay, so let's take V, and let's duplicate that node, 25, and feed it to U. Okay, so as you can see, it's automatically done the computation not in the way we want. So we just go right-click, lacing, cross product, and it's going to put, well, 500 points, which is a bit much, but let's go with that. First of all, I want to do put some sliders, and so I'm going to put slider and slider here, and put a couple of integer sliders. So U points. Okay. We don't want to go too high, so let's put 20 and 20 here. And we want a minimum of at least, let's say 4 on both, so it doesn't break the script. And I usually like to do the refinement a bit later, but sometimes when I know what I'm doing, I like to do the refinement a little bit early. So as you can see here in our image, we have a bit of a gap, like a margin, so to speak, like space around uh, the edge of the surface. Like these holes, they're not standing on the very edge. There's like a little bit of a distance. So to do this, we put a kind of variable. So it's going to be plus margin, and we want the same. We want to reuse the same distance. So we might put 1 minus margin, and let's say we want to have another slider. This time we're going to use a number slider. It's gonna do a minimum of 0, a maximum of 0. Let's put 0.25, and we want our step to be really small. So 0, 0. Let's see how that does. So I'm going to put my margin here, and so you can see as I let me zoom in into the 3D view. So as I go in here and change the value of my slider, you can see that I'm adding or removing some of the margin on the U parameter space. And we want to put that same here. So put plus margin, minus margin, and use the same margin value here. So as you can see, now I'm controlling the margin both in the U and V space. So it looks a little bit nicer. We can always change the maximum of that later on. Okay, I'm going to save and rearrange that and put more points to reflect the image that we have. So let's go here. That should be a little bit lower, a little bit higher here. All right, let's go with that. Right. Okay. Now we see that in this image we're using circles. So we have a node called circle by center point radius normal. So all these points here are the center points. So we feed them directly in here. Right now we can't see the circles because they're of radius 1, so it's just too small to be affected. So let's give them a radius of, I don't know, 10. Let's see what that does. Yeah, it's a little bit nicer. 20. Okay. Now we need the normals to orient the circles in the correct direction. So we use a node called normal at parameter, I think. Normal at point. Here we go. Here. You could calculate the UV at this point, but there's a shorthand note that's just basically, hey, what is the surface? Here it is. What are the points? Here they are. And all of a sudden, you got the normal vectors for all of these points, and that vector goes into the normal. And as you can see, all of our circles are correctly oriented, which is perfect. And so I think the next the thing I struggled while learning Dynamo is how to trim um, a surface with multiple objects. So in Alias, as most of you already know by now, you project curves onto a surface, and then you use a trim tool to decide which region you want to keep, discard, or divide. In Alias, it works, in Dynamo, sorry, it works a little bit differently. So you um, can't trim using curves directly, or you can, but only in very specific cases. The more fireproof, foolproof approach is to actually make solids and trim the surface with those solids. And that is a surefire way to get what you want. So let's do that right now. So first of all, we turn these circles or curves into solids. And I believe what I do is I do surface by patch here. And what it takes is closed curves and forms surfaces out of them. So if I turn off the visibility of my surface, which is here, you can see that I have a bunch of disks, non-planar disks, actually not planar disks, sorry, floating in midair, and I can thicken those to turn them into solids because right now they're surfaces. So thicken on, you can do one side or both sides. I always choose both sides. And the thickness, I usually go for pretty high numbers. Let's put 50. And you'll understand why in a second. So thickness. So why do I go for really high thickness values? Because you need to be sure that the solids that you are creating actually intersect with the original surface. So if I turn on the surface back on, you can see that it is each solid is fully intersecting with our original surface. Whereas if I were to go for seemingly low values, let's say, let's go for maybe 4, maybe not, no, okay, let's go for 125. On points where the curvature is not so big, your circle, your solid, will intersect with the surface. But on areas where the curvature is more pronounced, then the solid will have to be thicker or higher in order to fully intersect with the surface, which is why I always go very high values to make sure that I can visually confirm that all of my solids are intersecting with the surface. So, 25 is enough. Let's stay with that. And we're going to use now a node called subtract from. Subtract from, you can see it here. So it takes a surface and a trimming entity. So the surface is the surface that you want to trim, which is right here. And the trimming entity, if you hover onto the input node, it says it's taking solids. So, well, a solid, a single solid. And the problem here is that we have a list of lists of solids. So if I just go in and feed that into my trimming entity and turn off both the original surface and the solids, you can see that it hasn't actually trimmed anything. Oh, I need to turn off the original surface patches and maybe even so as you can see, there's a little bit of a problem. It actually hasn't trimmed, or it doesn't look like it has trimmed anything. So we need to turn these lists of solids into a single solid. So to do that, first of all, let's disconnect here. We need to flatten the list so that it's turning, we still have the same amount, but instead of having lists of lists, we only have a single list comprised of all 240 solids. But it's still not a single solid. So we need to transform this list of solids into a single solid, and we do that using solid by union, I believe, if I remember correctly. Yes. So it's taking a list of solids, a collection of solids in this case, and turning them into a single solid. So turn off this preview, and now let's turn off this one also. If I connect this to my trimming entity and wait a little bit, you can see that it has successfully trimmed all of the circles with their correct normals from my original surface. Okay, so but you're thinking, well, I can already do that inside of Alias just by projecting curves into my original NURB surface, but let's go a step further now. So let's start with, as I said before, using a core attractor point. So I'm going to turn off the preview of my curve so we can see a little bit more, a little bit better. We don't need the circles, we don't need the points, and we don't need the vectors. Let's turn them all off so we can see a little bit better. Now, let's start with a point, as I said. So point. And instead of entering the values, you may know this already, but it's quite a handy trick. When you switch to the background preview navigation, you can use the manipulators to, well, move the point into 3D space. It's actually quite nice. So in our example here, let's put a point quite in, well, it's actually in a pretty good place now. And sure. So we want to modulate the radius of the circles according to their distance to this attractor point. So first of all, let's rename it, call it attractor point. And we have our original center points right here. Okay, so let's do a distance 2. And it's going to calculate by connecting the points to my attractor point all of the distances. Perfect. But if I were to go ahead and feed those distances into our radiuses, or radii, should I say, we are going to get very big circles and it's going to look probably very ugly. And in our case, it has even produced an error. But if I turn on the visibility of these circles, you can see what that problem actually is. So we need to divide or reduce the values of these radii. So to do that, let's reconnect 20. We need to modulate this. So the method I usually use is remap range. So and yeah, adjust the range of a list of numbers while preserving the distribution ratio. Perfect. So our numbers are here, and it says new min, new max. So let's go for a minimum of completely random values, 2, and a maximum of 30. We can always change these up later. So our minimum will be 2, and our maximum will be 3. Actually, let's just follow our example where, yeah, as the circles get closer to the curve, they get smaller. So we're not actually flipping the maximum into a minimum. So we're keeping that up. Let's see if we get what we want. Yeah, okay. So we seem to be getting correct the intended result. And now we use radius. So it's going to take a little while to get calculated. Okay, so it's not as dramatic as I would have hoped it would be, but it's getting there. So now let's try to do that with a bunch of curves, or an attractor curve, so to speak. So this was just a basic example to show you how it works. Anyway, let's let's disconnect this and turn this completely away and turn back on our nurbs curve and our surface. Okay, so by the way, I'm doing this completely improvised, so it may go wrong or may go right on the first try. Just bear with me. So I would project that curve onto the surface first of all. Let's do, I think it's a pull onto surface, and this is our curve, and this is our surface, and we get a curve. Let's turn off this. Okay, so yes, okay. There's a little bit of a mistake as it appears. Let me just make sure that I like to use perimeter curves for surfaces, so I can still see what the surface looks like even though the preview is off like this. So we seem to have a little bit of an issue with using the pull onto surface, so we're going to use the project instead. Okay, so project a curve or geometry into a surface. This uses a solid, no, that's not good. So we and this project another. I know this works anyway. So this is the geometry we want to project, and this is our surface, and the projection direction is Z. So canon. If I type canon, it shows up the canonical vectors, and our projection vectors are Z-axis. And as opposed to Alias, Dynamo doesn't make a distinction in terms of if a vector is pointing up or pointing down. So in this instance, even though the canonical z vector points up and we need to project down, it doesn't make a distinction as long as the projection, the curve projected intersects with our original surface, which does here. So we do have our curve projected or curved surface in this instance. So how do we make sure that the curve on distance? Because if I just do this, as you can see, it's not exactly doing what I want. So we're going to have to find a workaround to do what we want. So instead of measuring the distance between a point and a curve, we are going to measure the distance between 2 points. And how do we do that? Is we're going to resample our curve into a bunch of points. So, um, so let's use a node point at parameter. So we reuse our curve and let's use, I don't know, a pretty arbitrary number of points. So our curve parameter goes from 0 to 1 and we want to sample, let's say, 20 points. Now we have seems to be an issue. Okay, so we have a list curve. And why do we only have a single point? That's interesting, to say the least. I am using the right. Okay, that's a little bit strange. Anyway, so now we have 20 points. Let's turn off surface. Okay, seems to be a small issue. Okay, yeah. Okay, so we have our circles. Let's turn that off again. Sorry about this. Okay. So now, why am I not getting the correct amount of circles? Normal vectors. Okay, let's reuse the value of 20. Okay, back to where we were. Perfect. Now, we're going to tell Dynamo to measure the distance of each of these points right here. Each of these points in highlighted blue to the distance of these points here. So we're going to get an unnecessarily high amount of distances, but here's what I'm hoping it will do. So first of all, let's put that away. Our first geometry is here, and the second is here. Perfect. So we should get, let's do cross-lacing. Okay, so we get 240. Which seems a little bit low, but maybe I need to use list at levels. Yeah. Go back to auto lacing. And I'll list the levels at L2. And here our points is also in a list. So let's use L2 also here. I should get 240 times 240. But for some reason, I'm normally getting... So wait, 240 times 240, that's 56. Yeah, okay, so we're probably going to go for lower values. Let's do 10 times 10. So we get 100 circles, and 100 by 20, that's going to be 20,000. Still going to be a little bit high, or 25. Yeah, that's a little bit more reasonable. Anyway, in this, so in this value here, let me zoom in, we get still awfully low. So we have 20, we should have 20 values per list. We don't have that. Actually, no. Okay, I see. So 100. Yeah, that's it. That's the one. Okay, perfect. So what we want to do is here take the smallest distance for each, and then modulate the radius according to that. So one. Okay, so we have nested lists unnecessarily. So let's flatten by 1. So we get cleaner lists. That's it. And now we're going to tell Dynamo to find the minimum item per list. Okay, so we have 100 distances, one for each of our 100 points. So we are on the right track. Okay. Now we have, and these become our new numbers. And they should be remapped here. 100, perfect. Okay. And here are our new radii. And that goes, let me just move my nodes. We don't need this anymore. I'm going to save and turn on the visibility, the preview for that node. Okay, it's slightly obstructed by the points. Okay, it's seems to be an issue. Let me just make sure I'm doing the right thing again. Okay, so yes, this is the problem. So I need to chop that list. And our length is 10. And that's based on or the U or the V. Let's double check. So let's crank this up to 11. And so it seems to be based on the U parameter. So the length, the V, sorry, here. Okay, 9 lists radius. And fingers crossed. Yes, perfect. So it, like I said, it takes a lot of practice, but if you keep at it, you will get there. So any questions, just drop a comment or email me at shinji.ponce@autodesk.com. Anyway, okay, so here we are. Let's turn off the curve and the intermediary points. Or, what I like to do is just Control 8, select everything, right click and hide all. This way I can only have to turn on the preview of this node. Yep. Okay, let me save. And so we don't need this anymore. And the only input parameters that we actually need are these three. So what I'd also like to do is group them, turn them to a different color, and call these controls. And actually, margin control. And all right, so, and oh yeah, and I forget the minimum and the maximum controls. So new min, new max, enter, and drag it on here. I may have said this before, but it's always good repeating it. If you want to add nodes to an existing group, you first have to click on the group, and then click and drag, no, shift click and drag, sorry, to select, and then right click, add to group, and they will be added to a group. Okay, so my only point here is that the new minimum is a little bit small. So compared to here, I mean, they are quite small here, but let's just crank up the number of circles, and by thus we also need to reduce the new maximum to something smaller. So let's go 10. And it's going to take a fair bit of time to compute. Oh, no, okay. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 25. and we have to wait a little bit. Okay, so it's the wrong direction, but it doesn't matter. 25, 30, save. Okay, we can delete unnecessary nodes. One thing to remember while using Dynamo is that even though it says that the run is completed on your bottom left, it takes um, another while for the graphics to update. Here we go. Okay, so it's quite fine. We can probably crank up the maximum. And to save a little bit of computing power and time, mainly, I'm going to turn off automatic and go to manual. And say much, it's divided by 2, so 0.3. And let's do 15 and compute this. And after that, will be ready to bake the trim surface back into Dynamo. Oh, Alias. Sorry, I keep mixing the two. Okay, runs computed. Right. Okay, it's a little bit close, but it's going to be good for today. All right, so now all we have to do is bake. Make sure your file is, I mean, we already saved it at the beginning of this video, but Dynamo requires that you save your Dynamo file on disk before making geometry. And we need to run. And once that run is completed, we should be able to see Dynamo geometry back into our Alias scene. Right, okay, here. And yeah, that's good. So, okay, so I'm going to go back to Dynamo, save and close this file. And as you can see, it says disconnected, which is perfectly fine. Yeah, that's a bug. Close the Dynamo tool, switch to pick object, because if you do pick nothing, what it does is it restarts Dynamo, and in some cases it might not be what you want to do, and I just did it. Okay, so let's go back to pick object and reclose our window. As you can see, our new surface is at the exact same point as the old surface. So we just do a pick object onto the Dynamo surface and hide unselected. And shape it. And as you can see, let me turn off the model. We have our trimmed surface, which follows our original curve. Here. And if I turn on a slightly nicer hardware shade, just to see it in its full glory. There we go. Okay, so it's intersecting with the ground, but you know, you get you get the drift of it. Okay, so one last thing is I'm going to upload the Dynamo file onto the GitHub repo. So if you go to GitHub, github.com/shinji/dynamo for Alias examples. And the link will be in the descriptions, and I am logged out. But if you go to this, let me go use Chrome instead. And I'm also logged out. Okay, so I'm going to use, oh, here we go. Okay, so as you can see, it's only got one file at the moment, but I will always be publishing the Dynamo scripts featured on the YouTube channel right here. So you'll always be able to go in and publicly download the files so that you can play with it in your own free time. Okay, anyway, thank you for watching this video, and please comment, like, and subscribe, and share it with your other Alias users. Thank you very much.